memory location, right? And it is the basic unit of storage in a program. So what we need to know is that whatever we do in Python, right, it more or less revolves around the use and the changing or the manipulation of variables. Okay. So the value stored in a variable can be changed during program execution. This just basically says that a variable's value can be changed midway through the execution of the program. That is, it can be reassigned to a different value. Let me show you a quick example. You might get intimidated by glancing at this whole thing, but trust me, just look at the first code cell, okay? What we are going to do is we'll create a variable and assign an initial value to it, okay? So let's create a variable named age, and to initialize a value to it, you use the assignment operator. So this equal to is called the assignment operator, and to the right hand side of this operator, we'll enter the value which we need to assign to this age variable. Okay, so this is how we assign a variable to a, assign this data to this variable. Okay, so if you want to print this variable, you will go print, and in simple brackets you type the name of the variable, and if we run this little play button thingy, we'll print 20. So in my second point, I told that variables can be reassigned. So I'll show you what I mean. After I print the age, I will change this age variable to another value. Okay. And if I print this now, print age, it will print 45. See? So variables can be updated as the program executes. So coming back to the slides. Okay, rules for creating variables. So when we create a variable, right, we should obviously give it a name, right? So, but there are certain rules that we should follow when creating variable names, so that the Python's compiler is able to understand what you're saying, right? So these are the rules for creating variables. I'll just skim through these. A variable name must start with a letter or an underscore character. So it must always start with a letter or underscore character. Otherwise, the Python will not recognize it as a variable name. The second point being, a variable name cannot start with a number, and two examples are beside it. A variable name can only contain alphanumeric characters and underscore. So alphanumeric characters comprises the capital letters from capital A to capital Z, and from small a to small z. That comprises this thing, and digits from 0 to 9, and obviously underscore. Variable names are case sensitive. So the three examples given here will obviously mean three different variables, and as Python is a case sensitive language, you must use the capitalization of variable names really carefully, okay? And the fifth and last point being, reserved keywords cannot be used for naming the variable. So you might have a question, what is reserved variable, right? So reserved variables, these can be understood as a set of keywords that are reserved, which basically means they can't be used as, you know, variable names or function names or for any other naming purpose, right? So these are understood by the compiler to be a certain thing, and you can't change that. So these were some rules for creating the variable names, and these are the reserved keywords which you can't use, right? So you don't need to study all of them. You, after programming for a couple of years, you will be familiar with all of these. So let me go back to my Colab, and I'll show you the different types of assignments that we have in Python. So the first line here is a string assignment. Why is it called a string assignment? Because the variable is name and we are storing a string in it. a string can be identified by single quotes or double quotes, right? So this is a string, and this is stored inside name. So this is a string assignment. The second is an integer assignment, which is because an integer is being stored inside a variable. The third one is special, right? This is called a floating assignment. Python actually recognizes integers and decimals as two separate data types. So decimal data types are also called floating data types in Python, right? So the third type is floating assignment, and the fourth and final type is Boolean assignment, which is uh, a variable which can store two values, can be either true or false. One thing to note is that the first letter, whether it be true or false, should be capital. As I said two times before, Python is case sensitive and you should take that matter into hands. So T and F in true and false should be capitalized. And if we print the four variables in order, we'll get the variable values as it is, right? So if you change this to false, we change false, right? So coming back now, since we know what variables are and the rules for naming them, let's move on to something that looks pretty harmless and useless, right? But it is of great use to programmers as well as somebody who happens to read their code, right? So I'm obviously talking about comments, right? So comments in Python are the lines in the code that are ignored by the compiler during the execution of the program. So the Python compiler, as it reads through the lines of code, it ignores that lines which are identified as comments, and it will go through with the rest of its job. So why should we use comments? So this is the following point. The second point explains exactly that. Comments enhance the readability of the code and help the programmers to understand the code. So it helps to document and helps to understand what the code is actually doing. And there are two types. There are single line comments and multi-line comments. Let me show you what that looks like in Colab. So this is a single line comment, right? How do I identify that? It is prefixed with a hash symbol, right? So whatever we type into this, if we prefix it with a hash, it becomes a comment, a single line comment, right? In case of a multi-line comment, it is characterized by triple quotes. Now, if we run this, it will actually show this, but that is not what we want, right? A comment should be invisible, and it should only be visible to the programmer and the people who read the code, not to the ones who compile and run the code, right? So to actually make it a comment, we should add a line of code, any line of code. Let me just print something under this. And if you have a line of code underneath this multi-line comment, it will actually vanish, right? It will only print ABC and it will not print this. So that is called a multi-line comment. It's a kind of a special case. So that is a basic overview of comments in Python. So this is a crucial part, right? So developers often have a need to interact with users to get data or to provide some sort of result, right? Every basic program requires some sort of input, right, from the user. If we need to add two numbers, we should ask the user which are the two numbers, right? So we should have the capability to receive the input from the user. So how do we get that? We get that using the inbuilt function called input. So what does this function do? This function first takes the input from the user and then evaluates the expression, while Python automatically identifies the data type. As Amrita said, Python automatically identifies the data type, and it will make our job easier. If the input provided is not correct, then either a syntax error or an exception is raised by Python. So if the variable that we are storing and the variable that uh, we are assigned to it is different, then it will have problems and the syntax error or an exception will be raised by Python. So maybe go back to Colab. So what we did is we created a variable named val and we use the input function. Input function goes like this, right? We go input and in square bracket, sorry, not square bracket, in simple brackets, we'll enter what should be shown on the output screen when we ask for the input, right? So we'll ask enter a number, right? So this will be asked, and when we input a number, this input is stored into this variable. Cool. Now, when we print this variable, it will ask for a number, and when we print, when we enter in 54, we print 54. Easy, right? So we can also know the type of input that the variable is storing, right? So we can use another input function called type, which maybe showing you here. So what we declared is a variable named num1, and we stored a value of 5 inside it, right? And we declare another variable called str2, and we initialize it with the string Python, right? So if we print the type of the variable, let's see what it prints, right? See, the type of variable 1 is an integer and the type of variable 2 is a string. See, so we can know what type of data that a variable is storing using the type function. And this is the same example that I showed. Now we move on to another important step, which is type conversion. So the first point is really important, right? So whenever you, whatever you enter as input, the input function converts it default into a string. So whenever we use the input function, the Python automatically converts anything that we enter into a string. So to convert it back to an integer or a float or whatever we need, we use type conversion. So you need to explicitly convert it into an integer in your code using what is called typecasting. Typecasting is another name for type conversion. So there are 4 types of type conversions, right? There is integer type conversion, floating type conversion, string type conversion, and Boolean type conversion. So just look at this example real quick. I initialize a variable with an input and I printed the type of that variable. So this comma might seem confusing, but what it essentially does is it prints the text here and followed by a space, it prints whatever value follows the comma, right? So it prints type of data and it will leave a space and it will print the type of the value. So this is what happens if you don't convert, right? If you want to convert this the input number into a integer, you will prefix the input with the function int, right? So if we have input enter a number, then, and if we prefix it with int, it will convert the string integer. Sorry, it will convert the string into an integer, right? So when we print out the type of data and the type followed by the actual function, this is the asking case of the first with no conversion, right? So if you type in 45, it will say it is a string. Why? Because it defaults into a string. And we haven't converted it yet into an integer. Now this, the second one that we are asking is of integer conversion. We converted it into an integer, right? So when we type 45, we should expect the type of data to be of class integer. And it is, right? So integer conversion is one of the three types, and we can similarly convert this to a float, and instead of printing, okay, we're not outputting it, right? So we can convert it into float for a float conversion, and we can convert it into bool for a boolean conversion. The boolean conversion is a special case, right? So if we initialize a variable called the boolean, and we initialize with the value of an empty string, right? There's nothing inside it. Then if we print the boolean conversion of this variable, it will print false, right? There is nothing inside it, so it will print false. And if we print anything, sorry, if we input anything into that boolean values, this boolean variable's value, we can put anything into it, right? So if we have a non-empty string, right, and when we print the boolean value of boolean conversion of that variable, it will print true, right? So if it is empty, it will print false, and if it's non-empty, if you have something inside the string, it will print true. Okay. So that was an example of type conversion. And before we go into strings, I need to show you a classic example of finding the sum of two numbers, right? So I'll do this from scratch so you two can follow along. So when we add two numbers, we have to first ask the user for the two numbers, right? So let me name the first number as first, and let me ask the user using the input function, and let me ask enter your first number. Now we similarly declare the second and ask for the input. Enter your second number. Now we have to find the sum, right? So we'll initialize a variable called sum and assign it the value of first plus second. Makes sense, right? We are adding the first value and the second value, and the result is stored in sum, right? So when we print sum, we should get the sum, right? So when we run this program and I put in 4 and 5, we should be getting 9, but what we'll be getting is 45. Why is that? Because we didn't convert our data types. As I said earlier, the input function defaults into a string. So Python is thinking that 4 and 5 are actually two words, and it actually joins them together. So that is not what we want, right? We need Python to actually identify these two as numbers or integers or floating point numbers. So what we do is type conversion. We go int and surround this with int. Same goes with this one. And now when we run it, 5 and 4, we should get 9. See? So that is why type conversion is really important, right? So we use it almost all the time. So that was a simple program to find the sum of two numbers. Now we'll go on to the strings part of the topic. It's actually a large topic, but I kind of took the important points and made it way smaller. So strings are defined as an array of bytes or a sequence of characters. So strings are strings are basically words, right? It's just a Python interpretation of words. An example is given here, and string can be categorized. It can be identified using single or double quotes, right? Whatever we enter inside single quotes or double quotes is identified as string by the Python's compiler. The second point is the basis of string indexing, right? So square brackets can be used to access the elements of the string. So every word in a string, right? Every character, every letter in a string has a certain address attached to it, right? As you can see in the below figure, H has the value 0, and E has the address 1, L has the address 2, and so on, right? The one thing to remember is that the first letter of a string will always have the address 0. Okay, keep that in mind. Okay, so strings in Python can be used using single quotes, double quotes, or triple quotes. I'll move on to Colab again. So, okay, this may seem daunting, right? Bear with me. First, we created a variable named college, and we initialize with a string College of Engineering Trivandrum, right? So what we'll be doing is called string indexing. So what we need to extract a certain character from this string, right? What if we need a certain letter from this string? All we need to know is the address of that letter, right? If we want C, we know that the opening, the starting address of any string, the address of the first letter is always 0, right? So if we use square brackets and inside it we enter 0, it will print the character that corresponds to the 0th location of the college variable, which is this string. Okay, so we should expect the capital C to be shown up, right? And it does. So if we print college of 1, we print O, college of 2, we print L. You get the idea, right? Now we'll move on to a slightly advanced topic of which is based on string indexing, called slicing. As the name suggests, it slices parts of the string, right? And slicing is done using the colon operator, right? And it requires two parameters, the colon operator, one to the left of the colon operator and one to the right of the colon operator. Two addresses are required. Why are two addresses required? Since both of them are the starting and ending addresses, we need both of them, right? So when I print college 3:5, it will print the third, fourth, but not the fifth. That is what I wrote here, right? It includes the first parameter, and all the way it will print up to and excluding the second parameter, right? So if I print 3:7, it will print the third, fourth, fifth, and sixth, but not including the seventh parameter, right? So if we comment out this, and if we print just this, right, we will get LEGE, which corresponds to the third, fourth, fifth, and sixth addresses, right? So that is one example of slicing. Another is when we print college 4. So there is no parameter which is to the left of the colon. So Python assumes that you are trying to print from the beginning of the string up till the fourth, not including the fourth. Got it? So it will print the 0th, first, second, and third characters. See, the first 4 characters will be printed out. And now, for the last example, I'll be printing college 3 colon and nothing. So, similar to the previous case, it will start at the third variable, and since nothing is there in the right hand side of the colon operator, it will assume that you will be printing up to the end of that string, right? So it will print the third character which corresponds to the third address, and will print all the way up to the end of the string, right? So when we print this, see, we get the whole thing, not including the 0, first, and second. So that was about slicing in Python, and we have some inbuilt string functions, right? So we have a bunch of string functions which are available in Python, which are available to you the second you initialize a variable as a string, right? So we know that college is a string, right? So this college variable will have some inbuilt functions called inbuilt string functions, and we can access these using the dot operator, right? So I'll give you some examples of these inbuilt functions. Some of these are upper, the lower, find, and replace, right? I'll be talking about each of these. We'll start with upper and lower, okay? So what we are doing is we are printing college dot upper, okay? So when we print this, it will convert all the letters of this string into uppercase, right? When we print this, the whole string gets capitalized. So what will be dot lower? We'll convert everything into lowercase. Only uppercase thing was capital C, and we converted into a small c, right? Now one thing to note is that even if you change the cases of the original variable, when we print the actual variable itself without any modifications, it will still remain the same, right? College.upper, college.lower doesn't change the original value of the college variable, right? So that is a note to keep in mind. It doesn't change the original variable. A second function is find, right? As the name suggests, it helps to find if a character or a word is present in a string. So if we print college dot find of, within single quotes, we provide the thing to be found out, right? Whether it be a word or a letter. And if we run this line alone, second line alone, we will get the address of the first occurrence of that letter or word, right? So what do I mean by that? When does capital C occur? In the first, capital C is the first word of the string, right? So it will return the address corresponding to that word or letter, right? Since we are searching for capital C and the address corresponding to the capital C is 0, since it's the first word, it will return 0. Now, if we print college.find of, similarly, it will return 8 because this is 0. C is 0, O is 1, 2, 3, 4, 5, 6, 7, 8. So 8, the 8th address corresponds to the first occurrence of this word. So it will return that. Okay, so that is the use of the find operator. Another similar type of inbuilt string function is replace, right? And again, as the name suggests, it replaces a character or a word with another character or a word. So replace, since replace needs two parameters, we'll be providing with two, right? We'll be providing it with the part of the string which needs to be replaced and the thing which it replaces. Okay, so if you want to replace Trivandrum with TVM, we'll go print college dot replace. We are accessing this replace function, and within single brackets we are providing two things. We provide the thing to be replaced and the thing it is replacing. Cool. So when we print this, we should get College of Engineering TVM, right? It replaced Trivandrum with TVM. All right. So another example is if I replace the with off. It's the same syntax, right? I use a replace function and I provide it with two words or characters. And when I print this, oh, it's not. I actually switched the two. So when I run this, it will replace off with the. Cool. Now the next and final operator from inbuilt string functions is the in operator, and it basically returns a Boolean value, right? It will check the whole string and will return if you have that character or not, true or false, right? So I am checking if I have the word engineering in the college, right? The college variable. So if this is my string, we should be getting true, right? Since engineering is present in the college variable. When we print this, it prints true. So what if we print something else? It's not present in the college string, so it should return false. Okay. So the final topic that I will be taking is string concatenation. So this basically means if we happen to use the plus operator on two data types which happen to be strings, right? We then Python will actually join them together. Like last time I showed you an example where I inputted 4 and 5, we got 45, right? So Python thought that 4 and 5 are strings and it joined them together, right? So this is the same thing. Hello is a string, name is a string. Why? Because we used it as we got the value of name by using an input function. Input functions always default into strings, right? So this is a string. This is obviously a string because it is surrounded by double quotes. So when we join these two using the plus operator, it will join them together, right? So if we say Michael, it will print hello Michael, right? It will join them together. See, so that is string concatenation, right? So if the operands, the two operands are of similar data type and both of them happen to be strings, then when we use the plus or the concatenation operator, it will join them together. Python will automatically join them together. Okay. So these are some of the inbuilt string functions. So, I mean, this might look really confusing, right? But don't worry, you don't need to buy at all of them. And that is it. And that is my time. So I'll be handing over the session to Amrita, who will cover the rest of the topics. Okay?
Yes. Hi, guys. Thank you so much, Nandu. Now I'll share my screen.
Yeah.
So now we'll be covering a few more topics, and I hope you guys can stay a little bit longer than until 7 because it's very important topics. We're going to cover conditional statements, and we're going to cover loops, and also the data structures we mentioned earlier. So do bear with me and to stay a little bit longer if you can, okay? And also, if you have any doubts, please just ask me. I have the chat open on my phone, so just like send them on chat. And if I'm going fast, please let me know because obviously the priority is that you guys understand what we're saying, right? So yeah, I'm gonna. Yeah, I hope you can see my screen. Yeah.
Yeah.
Okay. Cool. So our next topic is operators and operator precedence. So we had seen Nandu's program where we added two numbers to get a sum, right? So there we used an operator, which was the plus operator. And these operators that do mathematical functions are known as arithmetic operators. So here we have plus, minus, multiplication, division, modulus. This is something I'll explain now. And this is the power, that is something raised to something symbol. So you do 1 plus 2 and you do 1 minus 2. Here you do 1 into 2. And here if you do 1 divided by 2, can somebody guess what the output will be? Anybody on the chat? Anybody there? Yeah, it isn't 0, it's 0.5 because in Python, when you use a single slash, it is decimal division. But this double slash, right, that will give you the output 0. So unlike C, Python has that difference. So do keep this in mind. And the next one is the percentage symbol, which is the modulus symbol. So like the other programming languages, it'll give you the remainder of a division. And here the double star symbol, that is two multiplication symbols together, is something raised to something. So 1 raised to 2, 2 raised to 3. All of that would give, that would be with double stars. So the next one is assignment operators. You know what, I'll just show you the code and I think that'll be easier for you to understand. So yeah, here, I'm just gonna type it out. So first, I told you 1 plus 2, right? So I'll just print these out so that you get the idea. 1 plus 2, and if I run this, I get my answer. It's kind of slow. Yeah, I get my answer as 3. So instead, if I do 2 minus 3, I should get minus 1. And if I do 2 divided by 3, because it's decimal division, I get 0.6666 all the way until a few decimals. But if I did double slash, okay, so if I did 2 divided by 3, like you guys mentioned earlier, I will get 0 as the output. Okay, so 0. So double slash gives you an integer value, but the single slash gives you a decimal value. And next, if I do percentage symbol, it'll give me the remainder. So 2 divided by 3 is remainder is 2. Okay, and the next one is double star. So that is the power symbol. So 2 raised to 3 should give me 8. Okay, so I hope that was clear for you. Yeah. Can somebody respond on chat? Yes. Okay, thank you. So next, we'll see the assignment operators. So when Nandu had explained variables, we saw that we gave a is equal to 6 or a is equal to something, right? So this equal to is an assignment operator because we are assigning the value 6 to a. So when I print a here, what will I get the output as? It will be 6. Okay, so if I run, I get my answer is 6. So we're assigning the value 6 to a. So that means that equal to here is an assignment operator. So we also saw other assignment operators like plus equal to, minus equal to, multiplication equal to, and slash equal to. Okay, so we'll see how these work, and that will be, I'll give a plus a is equal to 6, and then I'll say a plus equal to 3. Can anybody guess what this does? Can you, if I print a now, can you guess what the answer will be? I think people who've already done some coding might know. Yeah, 9. You're all right. Yeah, so the answer is 9. So what this does is, I'll write a comment here. It'll be a is equal to 3. That's what this essentially means. So my a is already 6. And here when I say a is equal to a plus 3, it's 6 plus 3. So a is equal to 6 plus 3, 9 is the answer. So if I run this, I should get 9. Okay, so this is how the plus equal to assignment operator works. So if I did minus equal to, it would be a is equal to a minus 3. And if I run it, I should get the answer as 3. Okay. So similarly, multiplication equal to, and then division equal to, all of them mean that that particular variable is equal to that particular variable, and then the operator, arithmetic operator, and then finally whatever you're giving after that. Okay. So this is what an assignment operation is. So next we'll see comparison operators. So equal to, greater than, less than, greater than equal to, less than equal to, not equal to. These are the comparison operators that we have in Python. So let's take this example of a is equal to 6. A is equal to 6, and I'm going to say print a equal to 3. So what will my output be here? Can anybody guess? I'll give you a hint. It's going to be a true or false answer. So it's going to be false, yes. So that is because this operation, that is a comparison operator, checks if a particular comparison is valid. So here I'm checking if 6 is the same as 3. So 6 is equal to 3 would mean 6 is the same, has the same value as 3, right? But that's false. So instead, if I were to run a not equal to 3, so that is exclamation equal to 3. Now what would my answer be? It would be true, yes. So if I run this, I get the answer as true. So that's the use of a comparison operator. But if I also said a greater than 3 and I check it, the answer would be true because 6 is greater than 3. So it's checking if a value is true or false. And this will be very useful when you use if statements, while loops, and for loops, because you need to have a condition there. And this condition is what, this is how you check a condition. So this is comparison operators. And similarly, there's also greater than equal to, less than equal to, less than, which we didn't see, but I think you get the point. So I hope you guys understand so far. Yes? No? I think you do because I see a few. Yeah, okay. Thank you, Aishnavi. Thank you, Nikhil. So yeah. Next, we'll see the logical operators and, or, and not. So this same example, I'm just going to say a greater than 3 and a is equal to 6. Oh no, yeah, a is equal to 6. Can anybody guess if this gives true or false? What would be? Yeah, Atul, yes, true. True is the answer. Because this AND operator checks if both the conditions are true or not. So only if both the conditions are true, will this work. But if I gave a is greater than 3 and a is not equal to 6, then my answer would be false. Because even though a is greater than 3, a not equal to 6 is false, right? So if either one of the conditions or if both conditions are false, then because we are using an AND operator, my answer would be false finally. Okay. And if I use an OR operator in this case, what do you think is going to happen? If I run this, I'll get true. Okay. Because one of these conditions is true, it means that it is true. So if either one of the conditions or if both conditions are true, then I'll get my answer as true if I'm using an OR operator. And similarly, for a NOT operator, I'll just say not a greater than 3. My answer would be false here because A is actually greater than 3, and I'm saying that it's not greater than 3. So it's like, no, it's not true. So it's going to say false. Okay. So those are the logical operators. And identity operators, we won't cover that for now because we don't have enough time. And membership operators, Nandu covered it under strings. So that is to check if something is present inside something else. So in a string, if you're checking if it's present within a whole string, that is a membership operator. Okay, so next we'll cover operator precedence. So you might have studied BODMAS or PEMDAS in math. So that is brackets of division, multiplication, addition, and subtraction, or parenthesis, exponent, multiplication, division, addition, subtraction, right? So it's the same thing here when you do arithmetic operations in Python. So if I say print 1, no, I'm not going to say 1. 4 into 5 by 6 plus 5 into 4. What would the final answer be? Okay, wait, I'll give double division. What would the final answer be? Can anybody try out? It'll take some time maybe because it's quite a calculation. 20, yeah. So it'll be 20 by 6, and that'll give the integer value of 20 by 6. And then it'll add 4 into 2, so that'll be 20. So 23, yes. 20 by 6 would be 3 as an integer value. And plus this 20 would give us 23. So basic BODMAS that we follow in math is followed here also, okay? So that was operators. I hope it's clear so far, yes? Yes, okay. Okay, I can see 2 yeses. So yeah, I hope it's clear to everybody else also. And this is also something I'll type out. I'll just show it to you. Hello. Okay, wait. Hello. Into 10. So if I run this, I'll get hello 10 times. Oh wait. Oh no. There's a space here. That's not what happened. Yeah, so I get hello 10 times because multiplication is applicable to strings also. So if you put a string and then you multiply it, it just gets multiplied on and on, okay? It just gets printed those many times. So those are our operators. And next we'll move on to conditional statements, if, elif, and else statements. So conditional statements are basically something you would use to run something else based on a certain condition. Okay, so here if you see, I've given the syntax as if, condition, then statements. Okay, so it's used for decision making and to determine the flow of a program. So control flow statement, meaning it controls the flow of a program based on what condition you're giving. Okay, and here I've given a note indent. Indent is very important in Python because it indicates a piece of code, that piece of code belongs to a certain block. So we'll see how that works. So here I'll give an example for an if statement. So if, let's say 1 is equal to 2. Okay, this is, yeah, print hello, and then I'm going to say print yay. Wait, yay. Okay, so here we've seen this operator before, right? We've seen the equal to operator in comparison operators. So what it checks is if 1 is the same as 2, if 1 and 2 are the same, but we know that that is false. So it is not going to print this, and instead it is going to print only whatever comes after. Okay. Yeah, so I'll just show you another example just a minute. So if I say if 1 is less than 2, print hello. What do you think is going to happen now? Can somebody tell me what the output would be if I give this? Yes, it would give me hello, and then it would give me yay after that. So if I print this, it would be hello, and then it will give me yay, because here this condition 1 less than 2 is true. So because this condition is true, we print whatever comes, we run whatever comes within that block. And I'd mentioned indent, right? So here you can see that there's 2 dots that comes up. That means that there's 2 spaces. So this indent indicates that whatever is here is within this if portion. So if I say print hello and then I say the same thing again like 3 times, I'll just copy paste it because it's easier. Hello. So if I run this, all of these come under if, because there's the same amount of space before it. Okay, because there's 2 gaps, 2 spaces just before it. All of this will come under if. So here, if I give my condition as 1 is equal to 2, it'll be false, which means none of these hellos will be printed. It will just go straight over to the yay part. So I'm just going to run it and show you. Yeah. So in case it wasn't clear, I'll just show you the flow chart. So what happens is you have if, and then you come over to the condition. So if condition, if the condition is true, then you print the statements within the if portion. But if the conditions are false, then you move on to the rest of the code and skip whatever is within the if area. Okay, so I hope this is clear so far. So after this, what comes is else. Okay, so this is an example. And yeah, what comes after is else. So it is used to specify what to do if the condition returns false. So in this case, we have a false, right? 1 is not the same as 2, so we have a false. So if I say else and then say print by, if I get by and then get a yay, because it checks if the condition here is true. Is 1 equal to true 2? The answer is no. So then it moves on to the else part, and then it runs whatever is within the else portion. So I'll just copy paste this by 3 times also, just so that you know that all the statements inside will be printed. I mean, run. So yeah, by 3 times and then a yay. And here also you can see that the else and the if are at the same level of indent, and the print portions are at 2 spaces away from the rest of it. Okay, so this is how indent works, and this is how if else works. So next we'll see elif. Wait, I'll just show you the flowchart also. So if condition, and if the condition is true, then you go to the true statements. And if the condition is false, you go to the else statements, and then you move on to the rest of the code. Okay. So I hope this is clear so far, because we're going to move on to the elif portion. Yes. Is it clear? Yes. Okay. Thank you, Vaishnavi, once again. So the elif here is short for else if. So what we're trying to say is, if a condition is true, then do something. But if the condition, else if another condition is true, then do something, and else do something else. Okay, so this is used when there are multiple cases required, and it is only checked if the previous condition returns a false. And you cannot use an elif without an if block prior to it. So I'll show you that. So if condition 1 and then if statements, elif condition 2 and then another set of statements, and then another elif. This can go on for however long you want it to, and then statements within, and then finally an else, and then statements. So this e needs to be a small e, not a capital letter E. It's because I typed it out here that that's an error, but yeah. So I'll show you an example that I've already typed out, because that may be easier to understand. Yeah, this is the one. Okay, I hope you can see this example. Is there something like switch case that can be used instead of if else? Yeah, there is switch case available, but we won't be covering that here because we don't have enough time. So there is switch case in Python, yes. So yeah. Here we're going to look at this example. This is usually an example that they use in switch case also. So yeah, I'm going to take a user input for students' marks, and then I'm going to make it an integer, and then I'm going to check what their grade would be. Okay. So if I run this program, I get, I'm going to say that my marks are 70. Okay. I'm just going to run it and not show you what the answer would be for now. Oh no, wait. 70. And then I'm going to press enter. I'm going to wait. Okay. So what happens is I've given my input as 70. And then I'm going to come here and check if my marks are greater than or equal to 90. But we know that that's not true. 70 is not greater than or equal to 90. So it'll move on to the next statement, which is marks greater than or equal to 80. It checks if it's greater than or equal to 80, and that is also not true. So we're going to move on to the next one, and we're going to check if marks is greater than or equal to 70. So here it is equal to 70. 70 equals 70. So this condition is true. So that's why we'll print this statement, whatever is within. So we'll print grade colon B. Is that what we get? Yeah, we get grade colon B. So then after that, you see that none of these statements are printed, right? These Elif statements are not printed. This else statement is not printed because at this point, it just skips over the rest of it and then moves on to the rest of the code. So we've moved on to this part, which is great job anyway. Okay. So I'll give another input and show you. Does anybody want to say what marks to enter? Just for fun. 60. Okay, and I'll also enter 1. So 60, if I run 60, if I press enter now, yeah, my grade is C because I've given marks greater than or equal to 60. And it also says great job anyway. So also note the indent, okay? So here my if, Elif and else are at the same indent level, and all my statements within the if blocks and the Elif blocks are at the same indent level. So yeah, I got a 60 and I got my grade as C. And if I give 1, oh no, yeah. If I give 1, I will say, sorry, you did not pass the test, grade F. Great job anyway. Okay, and I'll also give 68, 40, and 110 just for the sake of it. 68, grade C. 40, you did not pass. I'm very sorry. And 110, it's an A+. Great job. So that's done. And that's how you use if, elif, and else statements. I really hope you guys understood so far. Yeah? Yes. Thank you, Karthik. Thank you, Vaishnavi. Thank you, Aaron, Bhavya, Srinand. I'm sorry. Yeah. So let's move on to the next topic. Yeah, this is just the flow chart. I think you understood it, but I'll just cover it anyway. So you give an if, and if the condition is true, you go on to the statements. But if it is false, you go on to the elif condition, and then you check that. If it is true, you go to the statements. But if that is false, you go on to the next elif condition. You check, and if that is true, statements. If that is false, then you go on to the next elif if there's one, or you go to the else. And then finally, you go on to the rest of the code. Okay. So I hope that is clear. And there's an example code. So yeah. Next we'll see while loops. So we've reached loops. So a while loop is used to perform a set of instructions repeatedly until a specific condition is satisfied. It's an entry control loop. And that is, the condition is checked before the statements are executed. So you can see the syntax here, which is while, and then you give a condition and then colon and then statements. Okay. So just like an if, here instead I'll just give while. Oh, and I also forgot to mention there's no need for brackets, okay, for an if-else condition, for if-else, or almost any condition in Python doesn't require brackets. I just gave it by mistake. So even if you give brackets, it's still going to work, but there's no need for it. So if I give, I'm just going to declare a variable a. I'm going to say a is equal to 0. And then I'm going to say while a is less than 5, colon. I'm going to say print I there. Okay. So what happens if I run this program now? Can somebody tell me? Is the output going to be correct, or am I going to get an error? What's going to happen? Yeah, it's going to go into an infinite loop. Great job, Arya. So if I run this right now, it's going to go into an infinite loop and it's going to keep printing hi there forever and ever. So that's because I'm going to stop this. Yeah, it's going to go on forever, isn't it? Yeah. So that's because here I've not given an increment for a. I'll show you how that works. So my value of a here is 0. And I'm saying while a is less than 5. So while 0 is less than 5. So first it checks is 0 less than 5. That is true. So then it will print hi there. And then it'll come back to the top and it'll check. But the value of a is still 0. So it'll check 0 less than 5. It is true. So it'll go on, print hi there, go back to the top, 0 less than 5. And that will go on forever and ever. So that's why it leads to an infinite loop. Okay. So in order to avoid this, you need to give an increment. So here I'm going to say a plus equals 1. So we saw this assignment operator earlier, which is plus equal to. So what we are doing here is a is equal to a plus 1. Okay. So that's essentially what we're doing here. And if I run this, now what will I get? Oh no, you'll see the answer anyway. So I get hi there 5 times. Okay. That's because first it'll be 0 and 0 less than 5. That is true. So then it'll print hi there. And it'll come here and it'll become a is equal to 0 plus 1. So my new value of a is 1. So it'll go back to the top of the while loop. It'll check 1 is less than 5. That is true. So then it'll come to the print statement, print it, and it'll come back here. And then it'll do a is equal to 1 plus 1. So now my new value of a is 2. And that'll go back to the top of the while loop. 2 less than 5. That is true. And then it'll come here, print hi there, and then it'll come back to the next statement. 2 plus 1, 3. Go back to the top, 3 less than 5, hi there. And then it'll go back to the top, 4 less than 5, hi there. And then it'll become 5. And then it'll check is 5 less than or equal to 5. 5 less than 5. We haven't given equal to here. So 5 is not less than 5. So that's why it'll stop there. And then if I give another statement here, print boo. Okay. So yeah, it'll print 5 times and then print boo. So that is 0, 1, 2, 3, 4. Those are the 5 times. And then it'll print boo. I hope that was clear. So this is how a while loop works. And yeah, because I've given less than, it's not going to print after 5. So if I give less than or equal to, it'll print 6 times because 0 to 5, 6 times. Okay. So next, we'll see lists. Was the while loop clear for you guys? Because it is very important. It is the most basic loop there is. Yeah. Okay. Thank you, Karthik. Clear. Okay. Great, Vaishnavi. So I hope it's clear to the others too. And let's move on to lists. So this is a Python data structure, which we had mentioned in the beginning, if you remember. So it's a most widely used data structure in Python, and it has square brackets and it has items that are comma separated. Okay. So the data items of any data type, be it integer or Boolean, can be added. And it is mutable. That is, it can be edited. So I'll show you what that means. I think I'm going to declare a list. So I'm going to say a is equal to square brackets 1, 2, 3. I'm just going to stop there. And then I'm going to say print. I'm going to say print a. Okay. And if I run this, I will get the same thing as the answer. So if I look at the type of a, so if I say print type a, and this was something that Nandu had showed you. So you'll see that it's class list. So the data type is, the data structure type is list. Okay, so this is what a list is. So the main thing about lists is that it doesn't restrict what data types you can add to the items. So if I can put integers and strings and float values, Boolean values, all of them in the same list. I'll show you. So this and this and also this. All of these can be added in the same single list. So if I print this, it won't give me an error because if you already know C or C++, you know that in arrays in C or C++, you can only add a single data type, right? But here in lists, there is no restriction. You can give any data type. Okay. So that's the basic thing about lists. So the next portion I'll cover with pre-written code because there's a lot and it'll take some time if I start typing it out, that is. So here I've declared a list named list1 and I've given the values 10 ABC 1.5435 and so I've included all different types of data types just to show you that it works. And I'm gonna print this. I'm just gonna copy paste it. Just yeah, I'll get the same answer, the one that you'd expect, right? So yeah, the next one is just a simple list with a single type of data types, and it'll also work. So I just wanted to reiterate that. So that's why I've added that here. And the next one is a list with just strings that says my name is Amrita, but with single words as single items. Okay, and here I've said print list1 within square brackets. I've given 0. So what do you think the output for this part of the code is going to be? Can anyone? Oh no. Can anyone tell me? Let's see. Yeah, it's going to be my correct answer, Shrinan. So I'm just going to run this and it's going to give me my, because as we saw in strings, each of these items is going to start, each of these lists is going to start with the index 0. Okay. So my first index, this first item, first term, that is going to be at the index 0. That is, its address is 0. So this is going to have the index 0. My is going to have the index 0. And then name is going to have the index 1. And then is going to have the index 2. Amrita is going to have the index 3. So there are 4. The length of this list is 4 because there are 4 items. The first index is going to be 0. Second is 1. Third is 2. And the fourth is 3. Okay. So if I say list 1 of 2, can somebody tell me what the answer would be if I print this? Yeah, that's the correct answer. So we'll have is. Okay, so I hope that was clear. And this is how you call out a single index of a list. So the next topic is multidimensional strings. So that is a list within a list. Yeah. So here you can see that I have 2 different brackets at the same end, right? Like both ends, I have 2 different square brackets. So that's because here, this whole GDSE, CET is one single term of the outside list. And this Google Developer Student Club is the second term of the outside list. Okay. And these individual, that is GDSE and CET, are individual terms of the first inside list. And this Google Developer Student Club is the only term in the second inside list. So if I call out list 1, and then if I give square brackets and give 0, what's the answer going to be? It will be this, just this. Yeah. So that means that the first term, the first item in the outside list is this whole list. Okay, that's how you know that this is a multidimensional list. So it's a 2D list because there's 2 different levels. And if I say 0, and then if I give another bracket and say 1, it's going to give me just CET. Okay, that means that the second, how do I put this? Yeah. So this is the second list inside this first list. Okay. So this might be a little bit difficult to understand because unless you try it out yourself, it'll obviously be very confusing. So anyway, I'm just like touching upon this so that you guys know what multidimensional lists are. Okay. So this is an example of a 2D list. And next we're going to cover slicing in lists. This is a very fun topic because there's a lot of different combinations you can try out. So yeah, So we saw indexing, and slicing is also very much like indexing. Okay, so it's just calling out specific indices of a list. Yeah, I hope it is clear so far. Can anybody reply? Yes, no. If I should repeat something, just let me know. And I'm sorry, it's 7:30. Oh no. I hope you guys are okay with staying. We'll just cover 3 more topics, just lists, and then we'll have for loops, tuples, and then we'll also just touch upon importing libraries. Okay. Thank you guys. Thank you for saying it's clear. So next, we're gonna see this. Yeah. Okay. So slicing. We saw in strings also that this is how you show slicing. You give the first index as the first parameter, and then the second index as the second parameter, but the second index will not be included. So if I say 1:4, what I'm saying is print the first term, include the first term, the second term, the third term, but then don't include the fourth term. So if I'm giving 1 to 4 here, what am I going to get the output as? What am I going to get for the output, right? So I'll just show that here. I'll get B, C, and D. So this is my 0th index. A is my 0th index. B is my first. C is second. D is third. E is fourth. And because we are slicing, the last index, the last value given here will not be included. This last index won't be included. So that's why we're getting the answer as the first index, that is B, the second index C, and the third index D. Okay. So that is basic slicing in lists. And now we'll also cover negative indexing. And that's going to get really confusing, but it's fine. So if you saw the PPT, give me 1 second. This is very zoomed in. But yeah, this slide. Yeah, that's fine. So in this slide, you saw this index, right? This -1, -2, -3, -4, -5. So that is negative indexing, because in the last term will be considered as -1, and then so on. Because the first term here we've already considered as 0. So if we want to go backwards, we'll have to start at -1. So -1 is the very last term, and then it'll go on from the back to the front. Okay. So that is negative indexing. So if I run this third, this thing, I will get just the last letter, that is E. Okay, so that is negative indexing. The next one is negative indexing and slicing. So we're slicing using the negative indices. So that is, here my value is -1, here it's -2, here it's -3, here -4, -5. So I've said -4 to -2. Can somebody guess what letters will be printed if I run this code? Out of A, B, C, D, E, what do you think will be printed? Can somebody try? B, C. Yeah. Okay, yeah, I think that should be the right answer. So let's just check anyway. So if I run this, yes, you guys were all correct. So it's BC that we get as the answer. So that's because this -2 will not be included, just the -4 and the -3. And once you run it, you'll have BC as the answer. Okay. Yeah, just give me 1 second. Yeah, the next one is, it has one more set of colons, if you can see. So that's because we can also specify the gap between each term, each item in a list. And that's what this 2 here is. So if I'm saying 0:4:2, I'm going to get the first 0 as the output. And then it's going to skip one term. And then it's going to give me the next one as the answer. So if I run this, I'll get the answer A. And then it's going to skip B. And I'll get the answer C. And then it's going to skip D. And because 4 is the last term, it won't get printed. So I'll just run this here. Might as well run this here. So yeah, here you can see I got A and C. That's because I've given my difference as 2. So that is if I look at 0 and then my next term is 2. So 2 minus 0 will give me 2. So the difference between the two terms should be 2. That's what I've specified here. In the general case, that is by default, that difference is 1. So if I do this, I'll get the answer as A, B, C, D. Yeah. Okay. So that's what the extra portion there is used for. So if I give 2, I'll still get the answer as A and C. And E is not included because it is at the 4th index. Last index not included if you've specified it. And the final example here, it is a special case where I've given the difference as -1. So what this does is it prints the given list backwards. So here my first term you can see is E. My second term is D. Third term is C. Fourth is B. And fifth is A. Okay, so it is going backwards. So if I print the first term of list 6, I've specified that here. So list 6, print list 6 of 0, I'll get the answer as E. Okay. And this is just a special, this is always used for making strings backward and stuff like that. So this is just something that you should keep in mind, ideally. Okay, so is it clear so far? Is slicing and lists clear? Yes, no? Yeah? Okay, cool. If I'm going too fast, just let me know, okay? Is this space okay? Yeah, okay, thank you. So next we will see, just give me 1 second. So next we will see, let's put this in present view. We will see list methods. So these are all things that you can do with lists, but there are also specific methods like we saw in lists that can be applied to a list. Sorry, that we saw in strings that can be applied to a list. So here, these are some of the list methods. I've typed them out because it's going to take a long time to type each one of these things out, right? So here I've given a list and I've given each item as A, B, C, D, E, F, G, H, I, J. So that's 10 items. And I've said print the list just to show you what the list looks like. So that is this. And here I've given the method len. So that will show me the length of the list. So len of L1, what will my answer be? Oh, okay, sorry, Amit, 042 once more. Okay, I'll just explain that and then I'll move on, okay? So this is used to specify the difference between each term, each item in a list. So my first term here is 0. I'll just type it out as a comment or something. My first term is at the index 0. So my first index is 0. My second index 1, 2, 3, 4, 5. So I'm going to check the difference between each of the indices. So I've given my difference here as 2. So when I do 2 minus 0, only then will I get the difference as 0, right? 2 minus 0 is 2. So it'll print the first term. It'll check the difference. Is 1 minus 0 2? The answer is no. And then it'll move on to the next one. It checks 2 minus 0. Is it 2? And then that is true. So that's why it'll print 2. And if I give one more extra value here, if I say F also, just to show you. So if I have 6 indices then, I mean 6, yeah. So here I've reached 2, right? So I've reached 2 and then it's going to start checking from there onwards. So it's going to check is 3 minus 2 equal to 0, is equal to 2. And that is false. 3 minus 2 is equal to 1, right? So next it's going to check is 4 minus 2 equal to 2. That is true. So then it will give E as the answer. So I'll just round it 0. Yeah, this is correct. So I'll have A, oh, sorry, I've only given 4 here. Should give 5. Yeah, it gives A, C, and E because the index 2 minus 0 is 0, and then the index 4 minus 2 is, the index 2 minus 0 is 2, the index 4 minus 2 is 2, and it'll go on until the end of the area that you've mentioned. I hope that is clear, Amit. If I can also explain it at the end of the session once again, if it isn't clear. Okay. Okay, thank you, Amit. Okay, so let's move on to the rest of the methods. So len, I was asking whether you can guess what the length of this string will be. The length, what the answer of this print will be. Can somebody tell me the length of this? Yeah, it's 10. So when I say print len of L1, I'll get the answer is 10. Okay. So that is the very first, the simplest list method, and it is very useful because you'll constantly have to specify the length of something, and sitting and manually finding out the length is just very tedious. So instead, when you use the len method, you can easily find the answer. So the next one is pop. So this pop, what it does is it pops the last term of a list. The last item of a list is popped. So if I do L1 pop and then print L1, my new list is going to be just A, B, C, D, E, F, G, H, I, and my J won't be there. So this is my new list. Okay. So this is how it's going to be. It's going to alter the already existing list, unlike the strings that we saw. Okay. So it's going to remove it completely, and you won't see it again. And if you want that item, if you want to see this item outside of the list and you want to see it also, then what you do is you say print L1.pop. Okay, so if I print this, I will get the answer J. Yeah, here you can see that it is J. Okay, so that is how pop works. And here I've given pop of L1.pop of 2. That means that I'm asking Python to pop the thing present at the second index. So here, what is it going to pop? Can somebody tell me? Yes, C. So if I run this, it'll pop C, and it'll give me the rest of the output. So it'll give me A, B, D, E, F, G, H, I. We have already popped J, and we also popped C here. So great job, Srinand. That was the correct answer. So that's how pop works. And the next one is remove. Okay. So remove, when you're using remove, you have to specify which item you want to remove and not the index. So here I've said remove G and remove H, and you can notice that I've given the single quotes because these are all characters, strings that I'm giving, right? So I've said remove G, remove H, and I said print L1. So this also alters the list, and it gives me the final list is A, B, we've already removed C. So I have the final answer is A, B, D, E, F, I. Yeah? Yes, that's what we got. So it removes those specific items, and that's how remove works. And finally, we have extend. So extend is used to attach a specific number of terms to the end of a pre-existing list. So you have to remember to use square brackets and parentheses for using the extend term. So that's extend, and then you give parentheses, and then within square brackets you mention what all items you want inside the list. So I've said and for 4.45, and you can see that these are all included in here. Okay, so that's how you use the extend method. I hope it is clear. We're done with lists. So I hope that was clear. Does anybody have any doubts, any questions? I guess that's a no. Should I repeat something from lists? It's clear. Okay, thank you, Vaishnavi. So next, we'll move on to the for loops. Thank you, Arya. Okay, let's move on. For loops. So here you can see that I've mentioned that it's an entry control loop, and it has a syntax for condition and then colon and then statements. But this condition is not the way you usually see it in C and C++. It's very different for Python. So I'll just show you those code snippets that I've already written out. So yeah, let's look at this one. Okay, so I've declared a list with 3 different names. I've given Ramesh, Suresh, and Savitri. So if I say for X in names, what Python does is it recognizes that names is a list, and I'm asking for a single item in a list. So for X in names is saying that for each and every item in names, check if this condition is true. Okay, so I'll just run this code and show you. I think that'll be better. So yeah, it prints Ramesh. So I'm gonna do this one later. I'll just do the normal one first. Yeah. Okay, let's just look at this example first. Okay, I've given for I in range 0 to 10 and then colon, print Python is fun. Okay, so here what I'm saying is I'm declaring a variable I, and I'm saying for I in range 0 to 10. So I'm giving I the range of 0 to 10, and I'm saying print Python is fun those many times. So here this final parameter in range, just like we saw in indexing in slicing, this 10 is not included. So I'm asking Python to print this statement Python is fun until from 0 until 9. So it's going to print 10 times from 0 to 9. So if I run this, I will get Python is fun 10 times. Okay. So this range function is very important when you're using a for loop. And you can also say range 10. If I just say for I in range 10, what this does is it automatically considers the first term as 0. So I'm essentially saying for I in range 0 to 10, print Python is fun. So that'll be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is not included. So if I run this, I'm still going to get 10 Python is fun. Okay. So this is how a basic for loop works in Python. I hope this is clear. Just like we saw in while, what it does is it checks. It's saying the first term, and then it runs the code, and then it does the increment automatically. It increments to 1, and then you go on to the next term, and then that's what keeps happening. I hope it is very clear, because I think I am not being very clear. I'll just repeat it once again. So I'm my first value of I is 0, and then I'll check is 0 less than 10, and that is yes. So then it'll print Python is fun, and once that is done, it'll go back to the top. It'll automatically increment to 1, and then that becomes 1 less than 10. That is true. So then it'll keep on going until it becomes 10, and when it is 10, it does not print because we are always checking less than in case of range function. So we've given the range 0 and up to 10, but excluding 10. Okay, so that is the for statement. And next we'll see another example using lists and for. Okay, so here I'm also using conditional statements, so it's kind of like including everything we've seen so far. So I've given 3 names, Ramesh, Suresh, and Savitri, and I'm saying for X in names, if this condition is true, break. Okay, so we'll see what all of this is. And then I've also said print X. So you can see that this if and this print X are at the same level of indent, right? So you can see how important indent is in this example. So I'm saying for X in names. So X is each item in this list, that is Ramesh, Suresh, and Savitri. Each one of them is an X. So first it's going to say, it's going to take the first X. It's going to take Ramesh. And then it's checking if Ramesh is equal to Suresh. And that is false. So then it won't do whatever is given within this if. And it'll go on to the end of the, whatever is given within the for loop, right? So it says print X. So I'm printing Ramesh. I'm just going to give another statement here just to show you. Hi. I'll also give another name in between. So I'll give my name, Amrita. Okay. I've said Ramesh, Amrita, Suresh, Savitri, and I'm going to keep doing this until I reach Suresh. So this is Ramesh, Amrita, hi. So that is because we saw Ramesh, we saw the example of Ramesh. It checked if Ramesh is equal to Suresh. That was false. So it came here, it printed the value Ramesh. And then it went back to the top. And for X in names, so it moves on to the next X, that is Amrita. So Amrita in names, and is Amrita equal to Suresh? That is also not true. So then it goes on to this print statement. It prints Amrita, and then it goes back to the top of the for loop, and then it goes to the next name, which is Suresh. And then it checks, is Suresh equal to Suresh? And this time it is true. So then it executes this break statement. So that is, it breaks out of this for loop and it skips the rest of the situation and skips everything else, and it goes on to the stuff after the for loop. So if you look at the indent here, this indent is within the for loop, but this indent is outside the for loop. The indent for high is outside the for loop. So that means that it is outside the for loop. But then this is within the for loop. Okay. So it breaks out, and that is how you use a break statement. That is how you call each term, each item in a list in a for loop. And this is also how you check using an if statement. I hope this example was clear. It's a little bit more complicated than every other example we saw so far. But this will cement your understanding of lists and for loops, I think. Does anybody have any doubts? Should I repeat this? I'm guessing that's a no. Yeah, okay, clear. Thank you, Nikhil. Thank you, Atul. So, should I repeat it, Atul? Is that what you mean? Okay, I'll repeat it then. So, what I'm saying is, each one of these items inside this list, so Ramesh, Amrita, Suresh, Savitri, each one of these I'm assigning the variable as X for a while. So I'm saying for X in name. So each one of these is X. But then first it will take the first X. So X is equal to Ramesh is my first situation. So I'm checking if X is equal to Suresh. So I've given X is equal to Ramesh. Then I'm checking if Ramesh is equal to Suresh. But that is false. So it doesn't run whatever is given within this if statement because my condition returns a false, right? So it doesn't run whatever is within the condition. So this print is within the for loop. If you look at the indent level, you can see that there's two spaces here, but before for there's nothing. So that means that it's within the for loop, but it is outside this if loop because if and print are at the same level. Okay. So that's why, because this condition isn't true, it goes on to the rest of the code, to the rest of the for loop. It'll print X. It prints Ramesh. And then it'll go back to the top of the for loop. It'll go on to the next name. That is, the next X becomes Amrita. So X is equal to Amrita. And then it checks if X is equal to Suresh. That is Amrita equal to Suresh? That is false. So then this condition is still false. So whatever is given within does not run. And then you come back to the rest of the for loop where it says print X. So I'm printing Amrita. And then I go back to the top of the for loop. So X. And the new X is Suresh. Okay, so X is equal to Suresh. And then I can check this condition. Is X is equal to Suresh? Yes, because our new name is Suresh. So Suresh equal to Suresh. That is true. So that means whatever is given within this if loop will be, if condition will be executed. And this break condition is something that is used to break out of a break statement is something that is used to break out of a for loop or a while loop. So because we've said break, it'll just skip everything else, just leave the for loop and come back to the rest of the code. That's why you can see that Suresh isn't printed, Savitri isn't printed. Because here it should, here we've given print after the break statement, right? And it is within the for loop, which means that we are leaving the for loop, so that also won't be printed. It'll just come straight out and it'll only print high. Okay, is that clear, Atul? Okay, I'm glad that was clear because it's important. So this is an example. And let's also, I've given an example of a nested for loop here, which is I've given one condition and I've given another for loop within the earlier for loop. And then I've said print Python is so fun. So here you can see that I've given the range 0 to 2. So 0, 1, and then here 0 to 2. So that is 0, 1. So it's 2 times the first loop will run, 2 times the second loop will run. So when you're in a nested loop, it'll be 2 into 2 times, 4 times this Python will be printed. Python is so fun will be printed. So that is, yeah. The first time it'll be with, it'll have I is equal to 0. And it'll come to the next statement. My j will be equal to 0. It'll print Python is so fun. And then the next time it'll go back to the inside for loop and it'll check and my value of j becomes 1. Okay. So it'll print Python is so 1 because 1 is less than 2. And then it'll go back to the top of the for loop and I'll have my I is equal to 1. So this time I'll come back inside and I'll have the new value for j as 0 again. So I'll have 0 less than 2. So I'll print Python is so fun once again. And then I'll go back to the j part and then my j becomes 1 and 1 is less than 2. So then it'll print Python is so fun again. And then I'll go back to the top. But then now my I becomes 2. That means that it's not going to work anymore. So that's why from range 0 to 2, 0 to 2, it prints 2 into 2 times. So this is a nested for loop. And even if you couldn't understand this now, I think if you try running this once by yourself with like different values, you will understand it better. Okay. And there shouldn't be the space in between. That's my mistake. So yeah. Next, we'll see tuples and we'll just see importing libraries. Oh, I haven't added anything there. Okay, so we'll see tuples and importing libraries and we'll be done. Okay, so just bear with me. 2 important topics, but very simple. Okay, so tuples are used with parentheses and they are comma separated. They can have any type of data type, just like we saw in lists, and they are immutable. That is, they cannot be edited once stored, only deleted. Okay, so we saw that in lists, we could do things like, where is it? Yeah, we could do things like remove and pop and stuff, right? And extend. This cannot be done in tuple. That's why it's called immutable, which means you cannot make any changes to it. Okay. So mutable means you can make changes, it can be edited. Immutable means no changes can be made. Okay. So I'll just take this example and I'll run it there because I don't think we have enough time to like sit and type it out. So here you can see that I've declared a tuple tup1 and I've given different types of data types, that is A, B, those are strings, and 1, 2, 3, those are integers. And in my tup2 I've given 12 and 34.56, that's an integer and a float value. So then if I print tup1 and tup2, you'll see that this is the value that's given. And yeah, you can see that that's the value that's given. And you can see that you can call each term, each individual index of the tuples as well, just like we saw in lists. Yeah. So here I've said tup2 of 0. So here I'm calling this value. Tup2's first index, that is 0, 0th index. And that's why I'm getting the answer is 12 here. Okay. The next I've called tup2 tup1 of 1 to 5. So we saw indexing, slicing in lists, and this is very similar. So I'm calling from 1 up to 5. So B will be printed, 1 will be printed, 2 will be printed. Okay. And 3 will be printed. Okay, yeah. Because I've said up to 5, not 4. So it will print 3 also. So yeah, if it was 0 to 4, then it wouldn't print 3 because I'm indexing it as 0, 1, 2, 3, 4. So it wouldn't print 3 if my index here was 4, okay? But because I've given 5, it prints all the way up until top. Even if I left it empty, it would run all the way up until the end, okay? So the next one is tup1 plus tup2, yeah. Here I've added 2 tuples into a third tuple. That will work. But then you can't change the first tuple by any means once you've saved it. So like I can change it manually here, but then I can't change it within the program. I can't say remove, I can't say pop, I can't say extend, I can't say append, I can't do any of those things because it is an immutable data type. Okay. So the only thing I can do is delete a tuple. And for that, I'll say del. Okay, I'll just remove these comment lines. Yeah. And if I run this, what's going to happen is my tuple 1 will get deleted. So this will give me an error. So my program will essentially just stop there. Yeah. Here you can see that in the beginning there was tup1. And here I've printed this thing, tup2. And I've called the value of tup2. I've called the values out of tup1. But then I deleted tup1. So when I ask Python to print tup1, it doesn't work. See, it says name error because it doesn't exist. The name tup1 is not defined. So you can delete a tuple, but you cannot edit a tuple. Okay. So that's the main thing about tuple. It's an immutable data type, and it's also used for storing different data types. So I hope tuples are clear. Yes, no. Yes. Yeah, you'll get this video on our community platform. So that is the place that you've logged in through, right? You'll get that video there. It'll be there in the event page, okay? So yes, thank you, Karthik, Shreen, and Binsi, and Nikhil. So we'll move on to the last topic, importing libraries. I haven't written anything here. It's not a problem, but yeah, importing libraries. I'll just show you an example, and that should be enough. So a library is something that's already present inside Python. It's modules that we saw in the beginning. Remember, I told you that in object-oriented programming, you're calling on different modules and stuff. And that's what we're doing here. Okay, so it's kind of like a different file from outside that you're calling in your program. So I'll show you an example, which is I'm going to say import math. Yeah, I'm going to say print math.py. I'll explain what this is. Why tuple when there is list? There are specific uses for tuples, which when you don't have to change data, right? Like you have to have that thing. It shouldn't be edited even by mistake. So that's when you use tuples. Okay. So its main function is that main purpose is that it's immutable, so you can't edit it at a later point, and nobody can edit it by mistake also. Okay. So I believe that's the main purpose. So I hope. Yeah, okay. Thank you, Javed. So next, I was looking at import math. Yeah. So this word import is used for importing the libraries in Python. Libraries or modules, whatever it is, into Python. So import math. Math is a module that is already present in Python, and it contains the word pi. Okay, so this pi is the pi we use in math, 3.14, the whole long number. So if I say this, it's going to print that whole full length pi value. So this is, I'm calling the method pi, this, sorry, yeah, the method pi, I guess, from Python, sorry, from math. So math here is a module. I've imported the module and I'm calling upon math.py, which is something that is present inside math. So if you consider math as a file, I'm calling a file. I'm saying there's a function inside this file. I want that. That's what I'm doing. So I've imported the file and I'm like, I want this thing within the file. So I've said this file, and then I want this function within the file. Okay. Another way to do this is I can say from math import pi. If I do this, I can just directly use pi. So if I say print pi, I'll get the same value. So I've said that there's this file. I don't want the whole file, just this part. So that's how you use import. I'll also show you another example. So I'll import numpy, which is the very first file, the very first module that you use in machine learning and stuff like that. So if you're interested in that, do Google once you're done with this. See, I import numpy as np. Okay, so that's how it's usually done because NumPy is a long thing to do, to type out. So everybody just shortens it to NP. This is just like the usual nomenclature. So import NumPy as empty. And then I'm going to make a NumPy array, which is np.array. Then I'm going to say, should work. Oh, I haven't printed it. I'll also print the type. So print type of A. It's almost 8. Oh no. So yeah, you can see that the type is a NumPy array, and this is how you can shorten something, and this is how you import modules into Python. Yeah, into your Python code. So I hope this is a useful session for you guys, and we really overshot how much we could complete within this session, but I hope it was useful. And we'll also share a form with you guys. Just give me 1 second. I will stop sharing my screen. I'll share a form with you guys, and this is a quiz that is that you guys can complete, and you can check whether you've learned something today. So give me 1 second. I will give you the form link. So how was the session, guys? Please tell me how it went on the chat. Thank you, Karthik. It was, yeah. I really hope it's useful for you guys. I will just put this link. There's some issue on my laptop right now. In any case, I'll share this link on the this thing as well, on the group as well. So it is fine. Just give me 1 second. I'll stop recording the session. Thank you so much.